Yep. I said it before and I'll say it again. Life moves pretty fast. You don't stop and look around once in a while, you could miss it.
Hey everyone, on DK's channel, my name is Colin Robb. I'm one of the partners here at Driven Dynamics. We're gonna go through a tour of our whole facility on what we have here, how we build everything, maybe some current projects we're currently working on, and showing you behind the scenes, which we don't really show many people, what we do here. Also, thank you to Podium 1 to really establish this connection where we're able to do this and have Dan actually come out here and see what we're doing. So let's go take a tour. I'm excited to show you guys, since this is our cave realistically. So our main lobby, we have, which I would probably, we have lots of photos on of me driving. Two, really exciting. This actual sim is a brand new build. That one is going to be going to a couple places, and after its time in the US, it's going to be going to the UK. We're finishing up that build, but this is kind of our main lobby. So we're going to start off in the R&D room, which DK, you've seen already.
Yes, it is amazing.
I love this R&D room, which I'll tell you guys, the R&D room for Driven Dynamics, this is our private room. So all of our testing, everything that we do here on products, building new stuff for our sim, you name it, is all in here. This is actually, this sim itself, is a couple iterations old, I think 4 iterations ago. So custom projector wall that we made. Sim is obviously by us. Yeah, this is everything that we do back here. So when we're making products again, we're designing new stuff, me and Alex, since we're here, we design, we put everything on this. This one is like the rough sim that we see how some of the stuff that we're doing that really opens up and see how it does, what's the reactions to it, really aiming for that realism that we're shooting for. This is our R&D room. No one's usually back here, so the fact that you guys are seeing it right now is quite cool. So we're gonna walk down the alley. Legends, Mario and Andretti. So once you walk down, I'll show you where everything gets built and how we build our simulators. So a big thing that we emphasize on, oh look, there's Alex, one of the partners at Driven Dynamics. One thing that we really emphasize on is that we do everything in-house. What I mean by that is that we write the software, we do the design work, we build everything. So we're the ones that are in complete control of everything about our simulator. If we want to make changes, we can. And a lot of the time when we're making changes, it's built back here. So currently, just to give you an idea, this one is going out. Where's this one going? I already forgot. This one is a new build. There's already a couple new pieces on this, which I would say Driven Dynamics, we're a very hard focused R&D company where we're constantly making revisions. We're constantly trying to make something better. We're trying to make our assembly time come down by building products that are easy to put on, because a lot of this takes a lot of time. It doesn't seem like it, but it does. Like one of the new pieces I want to show you really quick. That is exciting. That is probably, I would say, my new favorite part about our sim is our brand new, fully carbon pedal deck. This was designed by us. Obviously, we didn't make carbon fiber, but we are the ones doing a lot of the design work when it comes to our sim. So this to help us lighter weight, the assembly time is way quicker, and it looks really badass because I love carbon fiber. So that's just to give you an idea. And more as we're doing more things, we'll be able to change different things, which is quite cool. Another area that I can show you. So this is the, I would say, monocockpit. Then over here is the base platform. This is where everything starts. This has a good amount of pieces that put together. This takes a little bit of time, but this is how we start everything, and it's like a Christmas tree. So from the base platform, we have our actuators, which I'll show you over there, get stacked up. Then we put our monocockpit on, and then usually with whatever peripherals either that we recommend or Podium 1 has their specific peripherals that they want to use, they put that on there. So this is how it works, just like a Christmas tree. So we really build that up. So, but again, just to show you guys, we build everything. This is a new design. We always are making changes of it, and it's fun putting it together. It's like a big Lego. I don't know about you, Dan. I like building Legos.
Super fun. Always.
This is like a big Lego. But another thing I think a lot of people ask is about the actuators. I'll actually went over. These are built. Me and Alex just finished these. So these are all built by us. These are completely custom designed, from internals to how they work. It takes a lot of time. Once we're making these, we test them. Any product that we make, we test everything 100%. Once we have something that's out, we test it in here, we test it when everything's put together to really show that, one, it's functioning properly, and two, that everything that we want to work is working. So once it goes out to a customer or to anyone, we're not really having to worry about everything. But again, we make all the designs and everything. So it's quite cool to see everything come to this building. So we've gone through a lot of different iterations. Where's Alex? Alex! I gotta find Alex. Oh, wait. I know he could. So, Alex. Yeah. So I talked about the monocockpit, the base. Do you want to emphasize anything? Because you're the big brains.
Oh, jeez.
Sorry.
On the spot.
Big brain guy.
All right. Well, we already, I guess, did a bit of an overview on the actuators that we designed in-house. All right, so I can give you like a top to bottom on how these actuators work. So up at the top, we have what we call our top triangle that holds the actuators in the correct spacing at the top. From there, so we come down, this is all one piece, and then we have the sort of like pin that holds the spherical ball joint. Because on the top of a hexapod, you need 3 degrees of freedom, pitch, roll, and yaw, versus on the bottom where you only need 2 degrees of freedom from a universal joint. And up at the top, you can get those different degrees of freedom different ways. You could have a universal joint up here and allow this rod to freely rotate, but that has some other, pros and cons to it. So going down, we've got the spring retaining clip, which holds our counterweight springs on here. I mean, they look pretty cool. People think, oh, they're just there because they look like a car suspension. So they actually serve a purpose. They act as essentially counterweights. They take some of the gravity load off of our system so that the actuators have a more neutral balance of where the load is going. We have our shaft here, which inside this is hollow, and that's where the ball screw is hiding, is inside here. So this part slides in and out through a nose bearing here. We have our main housing here. Inside here is a ball screw and ball nut. So as the screw spins, the shaft goes out or back in. Here we have our 3D printed, it's a preload mechanism. So basically it compresses the spring to the right amount of preload. If we were building a cockpit that had a lot of weight out in the front, like some of our original designs, we'd actually increase the length of this to preload the springs even more. Moving down, we have our sort of hub here that has the safety brake mechanism in there, which catches the platform and just prevents it from having a sort of unexpected fall if there's either a power cut or if there's a mechanical issue or the actuators, if they overheat or shut down for whatever reason. This little brake mechanism in here will kick in, hold the system in place so it doesn't fall. And we did a custom design for that because all the ones off the shelf were too big. They added too much height to the actuator, which in turn messes with the ergonomics of the system as a whole. It makes it harder to climb up into the cockpit. It raises the center of mass of the cockpit, which is not great for a system like ours that moves so violently. And finally, they had one other drawback. They all rattle because when they're disengaged, they have a little friction pad in there that just sort of shakes it around in there, which fine on a lot of industrial equipment, not good on a system that runs haptics through the actuators like we do. So pretty distracting. So we had to build our own safety brake system. And then as we move down, we have servos. We have our custom universal joint. We went with a custom design, again, to save overall height on the system and still have the amount of degrees of travel that we need. So we need, on the joints for this system, we need between 30 and 40 degrees of rotation in both directions on these joints, which is hard to get from an off-the-shelf joint.
Awesome.
Yeah.
Really awesome stuff. Sweet.
But here we have a set of 5 plus 6 that will be going on the next sim that we're building. So basically we start with base platform, which has accommodations for forklift, pallet jack, wheels, and so on. This is the foundation of everything. From here we build up. Let's see. So those will go on here. Then we'll mount on the cockpit on top, as well as the peripherals and everything. What else do we want to talk about? There's all sorts of stuff. We've got a pretty good shop here. We've got all the tools that we need for basic fabrication, finishing, assembly, and so on.
Here's a question. Yeah, so been in business for almost 2 years. We've gone through how many iterations, I think, at this point, to make it to where it is today?
The actuators, I want to say we're on our maybe 9th iteration of the actuator design, and about to be on our 10th actually. So we're about to start ordering next batch of actuators, and those will be probably the 10th, maybe the 11th iteration, because there's the ones that you tried at my house a couple years ago, but there was even a design or two before that you didn't get to try. So we're always trying to make the actuators just more robust, easier to assemble, have less play, so that you can feel every little bit of detail that we're commanding through the system. The cockpit itself is on its 1, 2, 3. It depends on how you count it. It's 7 or 8 iterations of the cockpit to get to where we are now with the hexapod that you've all seen.
Which is exciting, and it goes to show when I say we emphasize how much R&D focus we really do. We're always making stuff better, from how it is related to what we're building, racing, and making sure that it feels the way it's supposed to feel, but also making it easier for us, but making sure that's the best product out there for reliability, for just detail, and like Alex said, for every bit piece. So we spend a lot of time building these, me and Alex.
Every one we build better than the last one.
100%.
If there's something that could be done more rigid or more efficiently, we're always making changes. we don't end up ordering the same batch of parts twice here, just because we're always finding something that we can do better. That's how we got to where we are with the platform feeling as good as it does. It's a lot of iteration on the design, right? We're never going to 100% lock it down, just because there's so much more stuff we want to do. So
no, that's exciting for us. And another question is, I feel like I like asking you questions. What do you think in the next what new products do you think we'll have coming out within the next year or two for the motion platform itself?
Oh, geez. Well, we want to, I think, Colin, you might have already mentioned this. We are looking at converting more of the cockpit over to carbon fiber, and it's cool, it's light, which is both really good things, and it actually helps with the motion that you feel in the platform, for there to be less mass, less inertia, more rigidity on the top. So there is engineering and technical reason to it. There's also a selfish reason. Carbon fiber lets me combine parts, which means we have a smaller bill of materials, less time spent assembling. So it is not a little bit selfishly driven. So we'll see more and more pieces on this system switch over to carbon fiber. And then beyond that, we have some exciting R&D in the work involving, say, G-forces. We've been going out to the track, doing a lot of measuring data collection on what you feel on the different parts of your body, like on your ribs, on your hips, on your legs, in a car when you're under high G's, so 2.5 G's, cornering, braking, whatever. Where do you feel it? How much do you feel it? Our goal, of course, is to replicate that on the simulator. So some exciting stuff there. We've got a lot of prototypes that we've worked on over the years, and we're slowly working on productizing those. So that's it. I don't know if we'll see it before the end of the year or not.
Probably not. But I want to emphasize, so we're not going to the track racing.
No, it's science. It's fun too, but don't get me wrong.
But
it's a reason for it.
Everything that we do is for a reason. And I'm actually excited about that product, because that has been a discussion, I think, for a long time, to build something that you can replicate G-forces, because people say it can't be done, but I
think we can get creative with it.
Yeah.
So yeah, like we go out to the track, we're there not just to drive, we're there for data collection, for validating that the sim feels like the real thing when you go out there.
Do data. We have a lot of data telemetry for that. Yeah. A lot of reasons, which thank you, Revolution, for giving us the ability to do that, and they see the value, and especially on the sim side of things, to really bring that level of realism to any space. But yeah, that's
interesting. What other stuff do we have going on?
I mean,
some developments on the display side. I mean, you guys caught the kind of version back there of the projector wall. We are looking into more immersive display technology. I mean, we don't show it a lot. Obviously, we support VR very well. It just doesn't show well on film, so you don't see it in a lot of our videos. But we are working on other interesting technologies for displays there. The projector wall is kind of more like a ground truth than anything else. But yeah,
I want to say a lot.
So much stuff.
Yeah, we really do have so much stuff going on. But either way, it's exciting. I think that the viewers are going to watch this. I hope in the next couple years, you'll get to see the evolution of what we're doing and how we're pushing the industry on engineering and creativity to that high fidelity into smaller form-fitted
something a little more accessible.
Yeah, 100%. I mean,
relative, but you know, to like race stuff, and like so many of them can't even really afford access to the good simulators out there just because it's millions of dollars. It's a dedicated facility, staff to operate it. And I don't think there's a good reason for that.
No.
So I think integrating technology, bringing that down to, you know, the consumer, or at least a form factor that, you know, like a race team could afford, that doesn't have, say, the budget of an F1 team.
But finding out a lot from even the higher level simulation of like how feeling comparable to what we're currently building.
We try so
which is that's wild to actually know.
Dan, you see something cool? I don't know. This may be one thing that Colin hasn't shown you, and you can show this if you want. You showed him the microcontroller? Yeah.
Good.
That's one of. So we do not only our own mechanics, we do our own software here. We do our own firmware and electronics as well. So this is kind of the system here is that board and microcontroller there that sort of coordinates all the motion on our system and is what enables us to run motion at 1,000 times a second. So we're able to do haptic effects, vibrations up to 500 hertz because of this. And I think that's really kind of like secret sauce of everything that's going on. Like we're the motion platform. It's cool, but the reason we built the motion platform in the first place is because there wasn't anything out there that could show off what I thought was possible in terms of how accurate the physics simulations are in these games right now. And so in order to do that, we had to build a hardware platform for it just to show it off. But it's about the software and the electronics kind of behind the scenes that maybe you don't see when you're watching our videos.
Yeah, quite a history too, which that can be long. I mean, this man, I feel like I'm interviewing you all the time. Alex started this, which I think is really cool, 8 years ago at his house. I mean, a hobby, and one when he was having his son to help him.
Yeah, I needed a new hobby. I mean, up till then, I'd just been working more at my software job. Which doesn't scale when you have a little kid at home. So I was looking for something new to do, something kind of creative and different where I could learn some new technologies and stuff beyond just software.
And then
what better way than sim racing? I mean, so many different fields, and there's such good data out there with the simulators. But
and what, two
years ago you came to
my
house.
I introduced for a friend and I saw, it's very hard to describe, but a very crazy design of a simulator. And I was working professionally for a manufacturer. And most people don't know, I'm a huge gamer, always have a. And I saw a sim, you know, for the longest time, you know, I built my own at home, you know, Logitech, that's from my house. I think that's the original one, just to give you an idea. Well, I think everyone starts off in, but a real car and going on the sim, like I never really felt like something was like real. I can really grasp on, that I can train on, that I can apply my skills to make them better, to go into the real car and do even better. When I went to Alex's house, what Alex was building, the first impression was like, oh my God, this is the most realistic thing I've ever felt. This is amazing. Like, how does this even happen? And where
I remember you saying, like, you've
Not a professional driver on this before.
like, how does it already feel this good?
Yeah.
I was like, well, I think it could feel better. That's why you're here.
Yeah. And I was working full-time for a manufacturer, doing a lot of pro stuff, and I was going to Alex's house when I had chances to come out, which now I'm a part of Driven, which that was 2 years ago, where we were doing it out of your house for a
good while there.
Yeah. And now we have a space. I would say we don't want to be super big, employee-wise and
Everything else, but like just
see the future of where we're going is quite cool. And we all love what we do, and we have a big passion for it, especially with my motorsports background. Like, I really want to make sure, and I would say maybe for Alex, is like, I want to bring that level of realism to anyone that hops on without having to spend crazy money, so that you can really, one, hone in on your skills, but two, apply it to, if you're actually a pro, semi-pro, whatever, to the real car. And then you can go back to like, wow, that sim really helped me for what I'm working on next. And I think that is really cool to see. And that makes me really happy at the end of the day. So it's a really big passion, and we spend a lot of time because we really want people to be excited about motion, making it not where people feel like it has a bad stipulation, but it's cool and where you can actually use it. So either way, we're excited, and I'm excited for the future for sure. So thank you for coming to Driven Dynamics. I hope you enjoyed this tour. We hope we see you somewhere around the world. We probably will be around the world somewhere.
Yeah.
I would like to be in Finland more, just to clarify that one. But we'll see you around. If you see us out in the open, feel free to ask us any questions. We're happy to answer anything for you guys. So we'll see you in the next one. Cheers.